Detailed analysis of the stealth structure of the B-2 Spirit aircraft. The B-2 Spirit is commonly known as a stealth bomber and is one of the most iconic and advanced aircraft developed to date. Its mysterious bat-like shape is instantly recognizable. But beneath that impressive exterior lies a network of complex engineering marvels, all aimed at a common goal: to avoid detection and secretly drop bombs on targets. The stealth structure of the B-2 is a masterpiece of modern military aviation, harmoniously combining materials, shapes, and technologies designed to deceive radar, infrared sensors, visual observation, and even sound detection. Overall structural design of the aircraft. The flying wing concept. The B-2 Spirit applies a flying wing design without vertical stabilizers, a traditional fuselage, or a tail section. This fundamental difference compared to conventional aircraft configurations is the key factor for its stealth capability, reducing radar signals. Without vertical surfaces like tails and rudders, it eliminates major radar reflectors that usually cause sudden reflection signal spikes. Smooth and continuous curves. The aerodynamic fuselage of the B-2 includes continuously curved surfaces and seamless transitions between the wings and the body. These lines help scatter radar waves away from the source instead of reflecting them directly. Minimal radar cross-section. The geometric structure of the aircraft is optimized to reflect radar signals from the ground and air in unpredictable directions, significantly reducing radar cross-section. These minimalist shapes, combined with internal weapon bays and concealed engines, form the foundation for the B-2's radar evasion capability. 2. Radar Absorbent Material, RAM. To complement its stealth shape, the B-2 Spirit is coated with a radar absorbent material, RAM, capable of absorbing radar energy instead of reflecting it. Carbon graphite composite shell. The outermost layer of the B-2 is made from composite material that not only provides strength and lightness, but also absorbs radar waves. This composite material is designed with sophisticated properties to disrupt and scatter radar signals. Ferrite-based paint and coatings. The surface coatings are specially designed to absorb electromagnetic energy. These coatings require careful maintenance, and to maintain stealth performance, the aircraft must be repainted periodically and undergo surface repairs. Multi-layer RAM structure. Layers with different dielectric constants are strategically arranged to optimize radar absorption over a wide frequency range, including frequencies used by early warning radars and fire control radars. The effectiveness of RAM heavily depends on precise manufacturing and meticulous surface maintenance, which is an important part of the B-2's operational maintenance system. 3. Internal weapons bay and air intake design. External protruding or mounted equipment creates radar reflection points, so the B-2 Spirit is designed as follows. Internal weapons bay. All weapons are stored inside the aircraft, and the weapons bay doors are designed and coated to maintain stealth capability even when opened and closed. Flush access panels, maintenance and avionics access points are evenly integrated with the surface to avoid disrupting the radar-absorbing coating. S-shaped air intake doors. The air intakes are designed in an S shape to prevent radar waves from reaching the rotating compressor blades of the engine, and these intakes are also coated with radar-absorbing material. RAM, shape, and exhaust protection. The exhaust is recessed on the upper surface of the wing combining cooling technology and stealth design to minimize infrared and radar signatures. By integrating these stealth structural measures, the B-2 avoids common radar reflection points associated with the engine air intakes and weapon mounts found on conventional aircraft. 4. Reducing infrared signals emitted from the engine and exhaust. Another important aspect of the B-2 Spirit's stealth design is reducing infrared IR emissions to avoid detection by missiles and heat-seeking sensors. Deep engine integration. 4 General Electric F118 GE 100 turbofan engines are placed deep inside the aircraft body so that the hot parts of the engine are not directly visible. Infrared reducing exhaust. Hot gases from the exhaust are mixed with surrounding air and cooled before being expelled through narrow, flat nozzles. This reduces the temperature of the exhaust flow and disperses the heat signature. Exhaust protection. The wing position and surrounding structures act as physical barriers, preventing the exhaust from being detected by ground-based infrared sensors. These infrared emission reduction technologies ensure that the B-2 is not only undetectable by radar, but also avoids thermal imaging systems. 5. Reduction of electromagnetic and acoustic signals. In addition to avoiding detection by the naked eye and radar, the B-2 is designed to minimize other detectable emissions. Electromagnetic emission control, EMCON. The aircraft's electronic systems are designed to operate in silent or low emission modes. Shields and filters prevent unwanted electronic emissions that could reveal its location. Noise-reducing engines. The F118 engines do not use afterburners and are optimized for quiet operation. Acoustic measures reduce engine noise, contributing to acoustic stealth capabilities at low altitudes. Lightning and static discharge protection. Conductive materials and grounding systems are integrated throughout the aircraft structure to prevent static discharge or electromagnetic emissions caused by lightning. These comprehensive signal control measures help the B-2 avoid detection not only by radar, but also by many other detection systems. 6. Maintenance and preservation of stealth capability. Maintaining the stealth structure of the B-2 Spirit is a complex and time-consuming process. Low observability, LO. Maintenance. Trained personnel meticulously inspect and repair ram coatings, surface joints, and composite panels. This includes precise surface finishing and repainting, surface contour management, deviations from the designed contour, such as gaps or depressions between panels, can significantly increase radar detectability. Therefore, the B-2 is rigorously inspected to maintain surface integrity. Storage in climate-controlled environments. The B-2 is stored in environmentally controlled hangars to prevent damage to stealth materials caused by humidity, ultraviolet rays, and dirt. The effectiveness of the B-2's stealth capability depends on the quality of maintenance, so a large portion of its life cycle cost is invested in preservation. 7. The trade-off between flight performance and stability. The B-2's stealth design poses aerodynamic and stability challenges. Lack of vertical stabilizers. This improves stealth capability, but reduces natural stability during yaw. The B-2 compensates for this with a fly-by-wire control system that continuously adjusts control surfaces. Split elevens and rudders. These combined control surfaces manage pitch, roll, and yaw movements without compromising stealth. The flight controller makes thousands of precise adjustments per second to maintain aircraft stability. Center of gravity and lift distribution. The flying wing must carefully balance lift and weight along its large wingspan. The internal structure includes sophisticated components to withstand these loads. Therefore, although stealth is a priority in the B-2's design, advanced flight control software and structural engineering are essential to ensure maneuverability and safety. 8. Operational impact of stealth design. The stealth structure of the B-2 provides several key operational advantages. Denied airspace penetration. With minimal radar detectability, the B-2 can strike high-value targets in heavily protected areas without the need for fighter escort or enemy air defense suppression. Survivability in high-risk environments. The B-2's design significantly enhances mission survivability, providing strategic deterrence. Global range thanks to aerial refueling. The combination of stealth design, long-range capability, and aerial refueling allows the B-2 to reach any target worldwide from bases on the continental United States. Conclusion. The stealth structure of the B-2 Spirit aircraft is a marvel of advanced aerospace engineering, combining sophisticated aerodynamics, materials science, and electromagnetic theory. Every element, from the wing shape to the radar-absorbing coating, is designed to avoid detection by the most advanced enemy systems. This design requires complex maintenance and poses challenges to flight dynamics, but thanks to its advantages in survivability, accuracy, and strategic range, the B-2 Spirit has become one of the most powerful aircraft ever built. As future adversaries develop more advanced detection systems, the inherent principles in the B-2's structure will guide the next generation of stealth aircraft.